Hello and welcome to episode 649 of the People Behind the Science podcast. This week, we are excited to be resharing our conversation with Dr. Christi McCarthy, originally published on May 23rd of 2016. Listeners, Christine's research examines the mechanical and geological features of ice and rocks. A particular focus of her work has been studying the friction forces that play an important role in how glaciers slide over bedrock. This work has important applications for understanding how the speed of ice moving from inland to the ocean may contribute to sea level rise in coming years. And in our conversation, Christine shared fantastic stories about her life, her career, and her work. So get ready to get inspired in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Today, I am excited to introduce you all to Dr. Christi McCarthy. So, Christine, thank you so much for joining us today. How are you?
Oh, I'm well, thank you.
Wonderful. Well, we are excited to chat with you about your life in science, but I want to take a moment here in the beginning to tell our listeners a little bit about you and your background. So, listeners, Christine is the Lamont Assistant Research Professor at the Lamont-Doherty Earth Observatory at Columbia University. She received her bachelor's in geophysics from the University of Oregon, and she went on to receive her master's and PhD in geological science from Brown University. Afterward, Christine conducted postdoctoral research at the Earthquake Research Institute at the University of Tokyo in Japan, and she was awarded a Lamont-Doherty Earth Observatory postdoctoral fellowship, followed by a NASA Early Career Fellowship, before she joined the faculty where she is at Columbia. Now, Christine is with us today to talk about her journey through life and science, so we are excited to hear all about it, and we want to get inside your head, Christine, and learn more about you as a scientist and as a person. So can you start by telling us what you like to do in your free time?
I used to, back before toddlers came around, I used to really be into rock climbing. I'm a huge fan of rock climbing and camping and all things outdoorsy. And now I haven't actually set foot on a wall in several years. So now it's all about going to zoos and museums and playgrounds and entertaining my toddler.
Well, that is awesome. Give them a couple years and they'll be racing you up the wall, I'm sure.
Exactly. She loves to climb.
Well, that is fantastic. Wonderful to hear more about you and your family. And I understand you have another addition to the family on the way very soon. So this is an exciting time for you.
Yes, definitely.
So now tell us a little bit more, Christine, about your scientific side. So I always like to give people the high level view of how you describe your work to someone who might not be familiar with your field.
Not knowing how much they actually want to know, I usually just start off with, well, I torture rocks and ice. And if they haven't walked away, then I continue. So you know that, for instance, an engineer, before they build a bridge or some kind of structure, they're probably going to take up the building materials, say the metal, and they're going to want to test it. What kinds of strengths can it withstand? Can it withstand these kinds of vibrations and things like that? So they'll use these machines in their labs to just torture the heck out of this metal and to understand its possibilities before they build. So in the same way, I use those same kinds of machines and those same kinds of tests, but instead of metals and thinking about structures, I'm looking at rocks or ice. And the motivation is not for some sort of building or planning, but to try to understand what happened to some geologic feature, or how quickly ice is going to flow, how it flows, or for instance, some icy satellite moon that is covered with ice, how it got to have some of those features on the surface or something. So that's sort of the motivation and the what I do.
Well, this sounds like a lot of fun. This is like a small child's dream, going into work every day and getting to play with rocks and ice and break them and smash them together.
It absolutely is. It's a dream job.
That is amazing. And I know a lot of people don't necessarily think of things like rock and ice as very dynamic, as deforming, as changing. So is this something that you face people wondering about?
Yeah, absolutely. So particularly if you're thinking about rock on the surface, our everyday interaction with it, it just seems like it's just this hard, brittle stuff. But deep in the earth, it actually deforms like silly putty or something. It really actually squishes. And we're talking, it deforms over geologic time. And so in the lab, we have to kind of speed things up a little bit so that we can actually get our PhD in time. But yeah, it actually deforms in ways like that. It flows like honey almost.
Really cool. I think you've got the great sort of analogies and descriptions for it here, Christine. I don't see how anyone would walk away if you started a conversation that way. So now we've talked a little bit about what motivates your research. I'm curious about what motivates you. Do you have a favorite inspirational or motivational quote that you use?
We'll get into in a minute, I guess, my strange sort of circuitous path to get to where I am now. But when I was at the very beginning of that stage, making a really huge leap to a new career, my brother and sister-in-law gave me this little chunk of metal with an inscription on it that I put on my cupboard and I look at regularly. And it says, "What would you attempt to do if you knew you could not fail?" And I like that because sometimes some of the leaps that I make seem absolutely crazy. What am I doing? And you just got to go for it.
I like it. That is a fantastic motivational quote there. And I like that you have a physical object associated with it too, that it's a reminder.
Exactly, yeah.
So now we mentioned your journey as a scientist and you mentioned it was rather circuitous. I'm curious to hear about where it began. Can you tell us about what is that spark that started your interest in science?
So you mentioned my degree at University of Oregon, but that actually wasn't my first degree. I actually got my first bachelor's degree in Long Beach State. I was a communications major. I was on my college dance team. I was obsessed with dance. I was also a choreographer and a coach for lots of teams in Southern California and just considered myself this artsy type. And that was the end of it. But when I decided to move on to my first career, I was actually as a paralegal in a law firm up in San Francisco and retired from dancing, looking around for things that interest me. And I started rock climbing. And that got me out into nature and got me looking at these amazing outcrops and just kind of scratching my head, wondering, trying to piece together the story. How did that get to be that way? At that time, I realized that the job in the law firm was interesting and there was definitely aspects of it that appealed to me, but I just didn't really love it. And I got this crazy idea that I wanted to go back to school and learn everything I could about geology. Even if that meant I never made a cent and I never went anywhere, I just thought that my life would be enhanced if I could learn more about the natural world. And so quit my job as a paralegal, went back to school, had to get a second bachelor's degree because I didn't have any of the scientific background with my first degree. And then from there, got into grad school. I really got passionate about lab work, and it kind of went from there. And you said some of the paths that I've taken, but it was really kind of a bold step to quit my job and decide, hey, I'm going to be a scientist.
So was it scary, that moment where you started thinking very seriously, like, all right, I'm going to turn in my 2 weeks notice from this paralegal sort of solid guaranteed job that you have and go into something completely unknown?
It was definitely scary, but it was not just a 2 week notice. I actually really adored the boss that I worked for. She was just a really strong woman, a lead partner in her own firm, and just a great mentor to me. And so I actually gave her something like 6 months notice.
Oh, wow.
And she was really wonderful. With her legal background, she didn't really know how to advise me about the steps that I should take to get to where I wanted to go. But she had colleagues and friends and fellow board members and things like that. So she would invite me to lunches with them so that I could kind of pick their brain and like, okay, what steps do I need to do? So she was really very inspirational and encouraging, even though it was a very crazy step. And in fact, when I went to give her notice, she didn't get angry. She just said, it's about time. I was hoping you would find that thing that drove you, and good for you. That was great.
Well, I think that's a sign of a phenomenal mentor. Even though she was losing a valued team member, she was interested in your best interest there.
And 15 years later, we're still very good friends and travel a little together from time to time. It's very nice.
Well, that is fantastic. So can you tell us about some of the challenges you faced, maybe going back to undergraduate to get the second bachelor's kind of later in life?
Indeed. The very first hurdle I faced, I could have been the deciding factor, I suppose. I should probably even see if I have the mind to do this. I should probably just start taking some night classes, take some math classes to see, can I do this? And I went to go take the math placement test, and I actually got placed into algebra.
Oh, no.
Oh, my God. Because it'd been a decade or more since I'd taken any math.
Right. Yeah.
And that could have been the deciding factor. In fact, a friend at the time said, well, maybe this is too much for you. Maybe you're dreaming too big. And I think that was actually the best thing I could have heard, because I was like, what?
Right.
Don't tell me that. I'll show you. So I actually kind of asked around, and it turns out one of the lawyers at this was a previous firm than the one I was telling you about. One of the lawyers had previously taught math. So can I buy you coffee a couple of nights a week? And can you remind me algebra? Mm-hmm. And then I went back and took the test and got placed into pre-calc. Okay, that's tolerable. And so I took my pre-calc and I took my calculus classes at night school while I was still working in the law firm. They definitely weren't easy, but now I had this drive. I had this purpose that I didn't have when I went to college the first time around. And I worked my butt off, and I got straight A's in those calculus classes. And then, okay, I can do this. And then went from there.
Well, that is an amazing story. I know I can relate to this feeling. When I was trying to study for the GRE, it's like, it's been years since I've had to think about the volume formula for like a cylinder. Like, I have no idea. You're really digging back there for some of those things.
Yeah.
So it sounds like you were able to overcome a lot of these challenges. Were there any other major failures or challenges that you wanted to talk about? Or was that the major one?
That was the one that I sort of had thought about. I mean, there's lots of challenges along the way. Grad school is definitely just one challenge after another. I feel like the main thing about grad school is not how smart you are, or how well you write. It's just, can you stick it out? Can you handle the pressure day in, day out?
Yeah, I think persistence is a major lesson that you learn in graduate school, how to not give up. You just keep going every day to lab and make things work.
Exactly. Don't let them bring you down. Yeah.
That's right. Now, you had some really interesting postdoctoral experiences. You spent some time in Tokyo. Can you tell us about that?
Oh, that was a wonderful time. So the experiment that I did for my PhD, it's called attenuation, but basically you kind of squeeze or tickle a material. And for my PhD, it was to try to understand how icy moons can dissipate tidal energy and make heat. But the same kind of response happens as seismic waves travel through the Earth. And so there was a woman, Yasuko Takei, wonderful scientist, Japanese scientist, who had done some theoretical work and wanted to do some experiments about understanding and trying to constrain how seismic waves travel through the Earth. And she wanted to run this experiment, wanted a postdoc. And it's not that it's the most difficult experiment in the whole world. There just aren't that many people that do it. And it was exactly what I did for my PhD. So she found me and I went over there, and it was just a wonderful 2 years. We got along really well in the lab. We had lots of great successes, got several papers out of it. But she, like me, just enjoyed her life, enjoyed this life in the laboratory. And every day we'd be giggling and having so much fun while also doing awesome science. And then my husband came with me, and after hours, we'd go explore this wonderful place. And we both fell in love with Japan immensely.
So were there any challenges when you were sort of transplanted from the U.S. into Tokyo for just 2 years?
Absolutely. I was actually writing and revising my PhD up until basically the week before I went there.
Oh, wow.
So someone who could have planned ahead maybe would have taken some Japanese classes or something.
I was going to say, were you fluent?
No, I showed up there not even knowing how to say hello.
Oh, no.
It was bad. And I have to say, we were there for 2 years and I got to take a class to do some remedial work, but I was really quite spoiled because Takei-san spoke English. And so all day long we would speak English in the lab. I'd go home and my husband spoke English. So I didn't have that same crazy motivation as other foreigners.
Sure.
And so I didn't pick it up probably as well as I could have or I should have after being there for 2 years. I think by the end I could have all my needs met. I could walk into a restaurant or a store and get what I needed, but I'm sure I sounded like a cave person, I think.
Right. So is there one thing that you maybe miss since being back from Tokyo?
Oh, gosh, there's a lot of things.
I just went to Japan last year, so it's fresh in my mind. Yeah.
Yeah, I would go back in a heartbeat. It's just a wonderful place. I think the thing that strikes me is just there's this social contract or something. Like everyone has this idea like, I'm not going to do this because how would that affect other people or how would that look on me? So no one would ever drop a piece of trash. You just hold that trash with you for 8 hours until you get home.
Right. And their trash cans are not always easy.
No, they're not around. And they have great systems of putting the elderly to work so that they're cleaning up the train stations. I mean, I live in New York City, and if you compare the two subway systems, you could eat off the floor in a Tokyo subway. Whereas in New York, if you drop something, that's dead to you.
Right. Just walk away.
I'm never picking that up again.
Well, wonderful to hear about your experience in Tokyo. Now, you also did a postdoc with NASA.
I didn't actually do a postdoc with them.
Okay.
So they have a system where when you're putting together your proposals, if the person who puts together, writes and plans the proposal is a postdoc, which I was, it was here when I arrived to Lamont. So I wrote a NASA proposal, and it was one of the few that got funded in that group.
Congratulations.
Oh, thank you. So you attach like a little CV, and if that panel says that, okay, so here's a PI who's a postdoc who came up with this idea herself, and we liked it enough to fund it, then they consider me as a scientist, and do I sort of have this future with NASA and planetary science? And they deemed that I did, I guess, that year. So,
sure.
So I'm called a fellow, I suppose.
Well, that is awesome. So we've talked about some of your role models and mentors along the way. Are there any that you haven't mentioned yet who really stick out in your mind as people who made a big impact on you?
There's been several that have definitely helped form who I am as a scientist. My advisor, Reed Cooper at Brown, helped me and really shaped who I was, particularly with my writing. Early on, Steve Kirby at the USGS, he was really inspiring. He came from sort of similar modest backgrounds and inspired me to reach out and aim high when I was applying to grad schools. But there's one in particular, Bill Durham is a scientist who also squeezes ice. He was at Lawrence Livermore when I first went to spend some summer weeks with him. He was the one who really not only inspired me, but gave me that first pat on the back that said, I think you're going to be a really good experimentalist. I think you've got what it takes for this. But didn't stop there. He then actually took me by the hand and showed me every step. And because there's an art to being an experimentalist. You really have to do 100 different steps and document each one and do the same thing each time and only change one thing the next time. There's so many step by step things.
Right. And how to fix every problem that you made along the way.
Exactly. And he just took the time to sit there and show me every single step and explain, not just this is why I do it. He said, this is why I did it, because something blew up 10 years ago. So we don't do it that way anymore.
Right.
I explained the whys. And that was just a huge thing for me. That was very early on. That was one of my first couple of years at grad school. And he's retiring now, but has continued to be sort of a source of, Bill, what do you think about this? What do you think about that? And he always gives me really good advice.
Absolutely. I think having those sounding boards, those mentors kind of stay with you throughout your career is really helpful. And talking about the human side of science here and referring to some of these role models, some of these mentors that you've had over the years, I think the people are what make science great. And I think there are so many different personalities, so many wonderful people in science who I've had an opportunity to work with and speak with. And when you get all these fun people together, some quirky things happen. I know I've talked to laboratories that have some crazy traditions. Do you have maybe a quirky tradition or even a fun story you could share with us about the human side of science?
Yeah, I mean, I guess it's not so crazy or so quirky, but basically working in his lab, the same person, Bill Durham's lab, this was this high pressure ice deformation rig that he had built 30 years ago or 20 years ago. And throughout the years, things maybe would not go well. Things got twisted, things got changed and tweaked. And he's very much a perfectionist, so everything had its place. And so once he taught me every little step and then he left me alone to run an experiment, it almost felt like a dance routine to me because I had to just shimmy up on top of this big rig, and each wrench had a specific place it had to go, and there had to be 3 clicks with this, and then you bang that, and then you turn this to the side with your wrist to be able to open it. And
this is an amazing visual, by the way.
Standing on one toe to get just right there and doing this by myself in this giant warehouse. Tweak, tweak, bam, bam, touch. It just felt like choreography. It just felt right with my past and okay, I like this. This is what I'm all about. But the funny thing is that after spending a week with him, shadowing him, learning every single thing, writing every meticulous note about roll this 3 times and then you add this oil, but not before this oil and things like that. Then he and his wife were going out of town and let me stay at his house and start showing me around the house. And he brought out his high pressure coffee maker and he started to explain this. And I just
oh man,
dropped my head and said, I can't take anymore. I'm just going to Starbucks. I'm going to be honest. I can't do anymore.
Entirely too many steps for morning coffee. Oh, that is awesome. Well, I love this parallel that you've drawn between your dance choreography history, the past that you had. So are you finding that you're able to still kind of incorporate some of this in your life? Do you still dance?
I don't dance at all, but I feel like there are aspects of what I do that satisfy that same need or feeling, I guess. In particular, as scientists, we can't just sit in a vacuum and find something out and then just let it lie. We actually have to get out there and describe our science to people. So we go to conferences at least annually, if not more. And you give a talk, a presentation, whether that's a 15-minute one or you've been invited someplace and it's more like 45 minutes. And for me, those almost feel like dance performances or something. So as I'm putting together my PowerPoint slide, it's like the choreography. I have to tell the story in some way that drags people along. Not drags. Hopefully I'm not dragging them. Leads them along and tells a story in an entertaining way. And then regardless of how many times I give a talk or what the format is, how many people are going to be there, it could be for 5 or 6 people or it could be for 1,000. I always get incredibly nervous, just like dance competitions. Like I can't eat, I can't sleep the night before. I'm very, very nervous. I give me a little like pep right before I go. And then I get that rush, and then it's absolutely just like doing a dance performance.
Absolutely.
In some cases, I think both my communications and my dance background, that creativity does, I think, do well for me. I mean, I'm not going to be the person in the room that develops wild, amazing new physics and new equations. That's not me. There are people that do that, and they're awesome at that. But I'm going to be the one who describes it in a way that hopefully gets people excited. I'm going to be the one that comes up with sort of a new take on it using my creativity, or presents it in a way that makes people have that aha factor. So we all have different strengths, and I'm able to use some of the strengths that I had from my dance and choreography days. My background isn't a hindrance. I think it is a help.
Definitely. And I think all these different talents are really important in science. And I totally agree with you. I feel like every time I get up on our little lecture stage when I'm even just teaching a class, all right, this is a performance. I have got to get these kids woken up after lunch and ready to learn.
Absolutely.
Well, fantastic to hear more about your experiences and kind of one of these funny memories from your earlier days. And now I'm curious to hear more about what you have going on right now. You've sort of been teasing us with all these descriptions of tickling materials and squeezing ice and all these kind of fun things you're doing right now. Can you give us more detail on a current project?
Yeah, I guess something interesting about what I do is that although there's a core to all of it, which is I try to understand how things at the microscopic scale, like how individual little grains move and interact, how stuff at the micro scale affects the macro scale, how a mountain forms, how a glacier deforms and things like that. So that lets me apply what I do to a lot of different contexts. So like I said, for my PhD, I was really excited about icy satellites. Then for my postdoc, it was all about seismic waves. The most recent thing I've been doing for the last few years here at Lamont is thinking about glacier flow. So how ice flows over rock, in particular, not necessarily the flow, but the friction. So I've been doing experiments where I slide ice past rock and try to just measure at different temperatures, at different speeds, what is the friction? What is that resistance to sliding? Because the motivation for that, of course, is that as we're trying to figure out, as not me, but as other scientists who do these really complicated models to try to figure out sea level rise and what's going on, mass balance of ice, one of the key aspects of that is how fast is the ice moving from where it accumulates in places like the middle of Antarctica, how fast is it moving out to the ocean? And so I'm trying to provide some of those values and try to understand some of that physics.
So what are some of the things at the micro level that might impact this?
Well, right now we've been working on things like temperature and velocity, but we're going to start adding funky stuff. We're going to start adding bits of clay, bits of till, and things like that that are probably a little more realistic to an actual setting, and see how that affects what's going on right at that interface where they're sliding.
Very cool. So do you do most of your work in the laboratory, or do you get to go out in the field and test things kind of in this more real world situations?
Oh, I'm one of those lab rats that I don't actually go into the field at all. So my version of field trips is to visit other people's labs. I've spent a month in Edinburgh because they have a really great ice friction group out there, and I spent some time with them. I spent some time in Japan. I visit other people's labs. I don't go out in nature.
Hey, well, I must say, I like nature, but I like controlled nature. So some of these crazy field expeditions people talk about, I'm like, I don't think I could handle that.
One of my good colleagues, a collaborator, actually, she's packing up right now, and she's getting ready to go out to Greenland, where they're retrieving some seismometers that they put out on some glaciers out there. And so I give her props. That sounds really awesome and exciting and cold.
Yes.
And so once she gets data back, we'll be able to compare that to what we're doing in the lab. And we do want to get those feedbacks. I think that even if I'm not the one that goes out into the field, we definitely have to talk to and collaborate with those that do. There's kind of a three-pronged approach to science where there's observation, you've got your seismometers, or you've got your GPS. There's theory, really trying to put together the physics and these complicated models. And then there's experimentalists who try to isolate aspects of those physics and really understand and constrain those. And so we all have to work together. We all have to hopefully get some funding and do our work and then share our stories.
Absolutely. And I think that way you can enjoy the benefits of this excellent real world data while remaining within your nice, safe, temperature controlled laboratory.
Exactly.
There are benefits.
Right.
So now we talked about some of your challenges earlier on in our interview, but I want to talk next about successes. I think it is so important to celebrate all the different forms of success in science. So can you share one of your success stories?
I probably could come up with several. I'm really happy with what I do. Every time a machine does what you had hoped it would do, you cheer and say, yeah,
right.
I'm excited. But the thing that's just at the top of my mind right now is that I did some experimental work during my PhD. So this is data that was collected in 2007, 2008, and wrote it up for my PhD. But the story just wasn't very clear. Basically, the short story is that it just got published.
Really?
Like 2 weeks ago, 2007, 2008 data.
Congratulations.
So yeah, it was kind of a more complicated system, but probably a little more closer to nature. I think it took me going to Japan and working on really isolating and identifying one aspect that I could then sort of parse out of my more complicated data. I don't know. It just took a lot, and it took a lot of back and forth with my advisor. And how many years later, finally, I got word that it got published, and it's just a huge success. I'm very pleased.
So then how did you celebrate once this project, years in the making, was finally published?
Well, I'm pregnant, so I couldn't. Our tradition usually in the lab is to bust open a bottle of champagne, and then we have champagne corks hanging from our ceiling. But I bought a bottle of Martinelli's.
Gotcha. Well, that is so exciting. And I know this is the case for a lot of different people I've talked to. Some of these projects just linger for years. So what kept you coming back to it, or how did you balance that with some of these new projects you were taking on?
I think that it was just really important data. Had someone scooped me and come up with exactly the same kinds of results, I might have lost hope long ago. But it just seemed like people were excited about it when I would talk about it. And it was new enough and really game changing that everyone kept saying, is this out? Is this out? I'm like, no, it's not out.
Well, I'm working on it. Yeah.
It kind of is like, I have to get this out. This is important and we got to do this. And my advisor never gave up on me. And we finally got it out there.
Well, that must be a really good feeling then, finally crossing that off your to-do list.
Yes.
So, congratulations on that fantastic success.
Thank you.
And we've talked about a lot of different aspects of your life in science. And I know scientists are always reading, trying to keep up with the literature, having a million other things on their list of things to do. It doesn't always leave a lot of time for reading for fun. But I've been really trying to make a conscious effort to dedicate some book time in my life. So can you recommend a book for me and my listeners that you've really enjoyed?
It's hard to find time to read. I know back in my 20s, I was a huge Wallace Stegner fan, and I remember I loved All the Little Life Things and Angle of Repose, and those I think have a slight, particularly the latter one, a slight geologic slant to them. But to be honest, these days, all of my reading seems to be about how to feed, sleep train, and entertain a toddler.
Very nice.
So the only thing I actually do have time for is short stories. So I will read anything that David Sedaris ever writes, and he recently had a hilarious article for the New Yorker, a little bit about shopping in Japan, shopping in Tokyo in particular. And I just thought he captured it quite well, actually, to be a foreigner in Tokyo. Yeah. It was awesome. So definitely check that out.
Awesome. Yeah, I must say he is hilarious. I have enjoyed his work as well.
Yeah. So
does your toddler have a favorite book right now?
Oh, I should know it, but it changes daily. Right now, she's reading the toy catalog.
Ooh. Is there a birthday coming up, maybe?
So yeah, in June, we're force feeding her maybe, but she's got a whole pile of books about waiting for baby brother and how to be a big sister. Mm-hmm. So far, she hasn't rejected these, and she seems pretty excited about those and about baby brother coming.
Well, that is fantastic. So thank you for those book recommendations. And I know we've talked about some of the travel that you've done as a part of your career, particularly your trip to Tokyo. And I think this travel is a huge part of life as a scientist. So can you think back now, Christine, on all the places you have been for science and tell us about your absolute favorite?
I've been to a lot of really fun places. Every now and then we get to go to Europe for the EGU conference, like the European version of our big geology conference. And that's always fun. And I loved my time in Edinburgh. But I really got to say the whole time that I was in Tokyo was just heaven. We really got around to all of the places where the guidebook recommends, but we were there 2 years is long enough that you can even add on to that. And so we were going off the beaten path. And after 2 years, we actually spoke enough Japanese that we could do that. There is this string of islands that are just south of Tokyo that you have to take this big ship and you don't get a seat. You just bring your blue tarp and you stand in a huge line and you find some place, some little 4x4 foot square place that you can place down your blue tarp, and you just hang out for 12 to 15 hours until you get to your particular island.
Oh, wow.
My husband and I did a couple of islands on that trip, and it was just amazing. Hardly anyone spoke English on these islands, and we just had an amazing time. And there's more. I could probably talk about Japan.
That's a whole another hour. Yeah,
exactly. Yeah. It's just a fabulous place.
I was trying to convince my husband. I think there's an island that has just a bunch of rabbits that all just kind of roam free. I was trying to convince him to do that, but he was not on board. So. Oh, that is amazing. And I love this idea of you being able to stay there for 2 years. So not only being able to check out these kind of touristy destinations, but really get off the beaten path.
Yeah.
So is there any like one thing that you remember as sort of the iconic image of your trip to Japan?
I guess it's very Japanese. They had at the Earthquake Research Institute, they had an annual party, basically a summer party, and they would have a barbecue and they'd have people hammering mochi, hammering rice powder. And they had this large, it's kind of warm, a large chunk of ice that would just sit there in the middle. And I asked, what is that all about? And that's supposed to make you feel cool.
Oh, of course.
By looking at the ice.
You can emulate it. Yeah.
Yeah. And a lot of folks would wear yukata, not a full kimono, but a summer version of Japanese dress. And they dressed me up in one of these. And so my husband and I snuck back into the lab, and he took a bunch of pictures of me doing all of my lab work with the yukata. Yes. For quite a while. Would continue to use those as slides in my talks. Like, just a typical day in the lab. Just
right. Totally normal. Everyone dresses like this. Yeah.
Yeah, exactly.
Well, that is amazing. Christine, thank you for sharing some of your Japan memories with us today. And I know we've talked about some aspects of your research, and I love picking scientists' brains about the big questions that remain unanswered in their minds. And I think everyone has at least one. So can you tell us today if things like funding and staff and technology and feasibility, all these normal barriers in science were out of the way, what is the question you would want to answer?
It should be something amazing like curing cancer and all of that, but that's obviously not in my skill set. I am just super fascinated with what's going on at that little micro scale. And I have this crazy idea and I would love to pursue it, but no one's going to fund me to do this, or at least I haven't yet found the agency to do this. But when you mix ice with other stuff, it really gives very different properties. It could make a really strong material that could be sliced, for instance, if you're using like gelatin or something. And as NASA is developing missions out to the outer solar system, and folks are thinking about the long term and not necessarily colonization, but setting up stations and things like that, you can't bring building materials with you. The payloads just don't allow that. So you have to use what you have available. And so if you're going to, say, Mars or something like that, you have to figure out how to turn the rock into some building materials. Or if you're going to an icy satellite, you would have to be able to turn the ice into something that you can build. But ice is inherently brittle. So I would love to develop some research to really test the best thing to mix with ice to create really strong, resilient materials that you can use like a 3D printer to create. And actually, it's not so far-fetched. Actually, NASA has had a competition, but for the most part, the folks that were in it were architects and designers, and they were thinking about the structure, whereas I would really geek out over the material, over making some kind of perfect, ideal ice plus X mixture. It's a little out there, it's a little extreme, but it also seems like, what if you were the one that participated in building that structure that survives for millennia because it's out there? Anyway, I would love to do that, but it's probably not going to ever happen.
I think that is so cool. I love this image of building awesome ice forts, it sounds like, out of all these different materials.
Yeah.
So do you think the components that you might combine with ice to make it stronger, are these things that you might find on somewhere like Mars or other places, or are these things that in your imagination would have to bring from Earth?
I think you probably have to bring those, but probably you can get them in the most
compact form or
exactly. Some sort of polymers. That's my thought.
Gotcha. Well, I like it, Christine. Thank you for thinking big with us today.
Thank you.
I know we've talked about your path as a scientist, and we've kind of gone over some of the people who've inspired you and guided you along your journey. And I think these people are amazing sources of advice. And I love giving our listeners some advice that they may be able to apply to their own lives, their own careers, to help them as they move forward. So can you think about what is the best piece of advice you've ever received?
I've gotten a lot of great advice. I've gotten a lot of great mentoring. But the thing, I guess, that just always comes back to me is my parents had only high school degrees. They were mainly blue collar. So they didn't have some sort of weird like mold for me that they needed me to fill. They basically just said, you can do whatever you want. Whatever you set your mind to, you're going to do. We could tell. Because I did well on tests and they thought, okay, you've got this aptitude, but you just need to find the thing that really drives you. And whatever you want to do, you can do. That's the kind of encouragement you want from your parents, not like, oh, you have to go to law school or, something like that.
Right.
Like, this really kind of open box support. And they didn't understand at first, like, you're going to quit your really good paying legal job to go back to school to do what?
Right. Rocks, you say.
All right. Well, that's great to hear. What can we do? That kind of thing. So they've always been really, really supportive.
Absolutely. And I think that support is key. And I myself am fortunate to be in that same position where when I was young, my parents were like, reach for the stars, do whatever you want. And I think that's something as you're getting older and starting to raise a family of your own. I think many people out there might be in this position where maybe their kids are interested in science and they're not really sure how to cultivate that. And I think that's something you just kind of let people pursue what they're passionate about. Let your children pursue what their big dreams are and do whatever you can to support them. I think that's awesome.
Yeah.
So now, is there any other last piece of advice, Christine, or maybe one note of inspiration that you would like to end our conversation on today?
Just a little bit, just to remind people that if they weren't following the time scale that I was talking about for my career, that like at the age of 30, I was sitting in Physics 101 with 18-year-olds at the University of Oregon, starting completely fresh, miles and miles away from friends and family, just doing it. So I guess I want to say it's never too late. Whether you're in high school, whether you're in college, whether you're someone in your 30s not happy with your job, figure out what you like to do. Don't just wait for things to happen. Figure out who you are, what you like to do, what you want to do. And then, here's a key step. Reach out to people. Like I had reached out to my mentor at the law firm, and she tried to connect me to people. They're not going to make you skip 10 steps, but they can hopefully tell you what those first 10 steps are to get to that goal that you have. And then just do it. It's never too late. You can be a 30-year-old, a 40-year-old, a 50-year-old in classes starting from scratch. And it's humbling, but it's so exciting. And it gets you to a place like this where I have my dream job and every day is just a joy.
Well, that is a phenomenal note to end on. Christine, listeners, definitely take this to heart. It is never too late to pursue your passion. Now, Christine, can you tell our listeners where they can go if they want to learn more about you and your work?
Great. So again, she mentioned I'm working at Lamont-Doherty Earth Observatory at Columbia University. So if you went to Lamont-Doherty or just LDEO, you can probably find my website and then also email information there.
Perfect. Well, thank you so much for directing us to those resources. And thank you for joining us today for an interview, Christine.
Oh, thank you so much for having me. It was really nice chatting.
Well, it has been a pleasure to speak with you. And listeners, as always, thank you for joining us. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.